Hello and welcome to this video on how it is the annoying, buzzing, biting and blood-sucking pests called mosquitoes see and sense you. Have you ever wondered how it is that a mosquito, or worse yet a swarm, can find you in the middle of the night when everything is dark and nothing should be able to easily find you? Sure, smell might be one way, but this doesn't work as well in the wilderness where many competing smells exist. Sight is obviously not an option at night. Mosquitoes must have something more than just one of these senses or find a way to combine them. Mosquitoes do primarily rely on their vision, we'll be clear about that. Although, to an extent, it's not so much for detecting you, it's more so that they can get around in the environment. Mosquitoes, similar to flies, have compound eyes. That is, eyes made up of thousands, if not many more again, tiny individual visual units. These are called matotidia. They provide a wide field of view, almost entirely 360 degrees, although slightly less in some species. These eyes help in part to detect movement and very basic rudimentary shapes, rather than allowing them to see anything in detail. This means that they can see at a reasonable distance and just about everywhere at once a moving object, like for example a human. But this isn't always useful, as we mentioned, particularly at night time when, well, they can't see. Mosquitoes themselves do see well during the day though, and they're reasonably sensitive to wavelengths of light in the red, orange and black spectrum, and some can even see ultraviolet light. This does prove to be useful, particularly at night when your body does emit a degree of ultraviolet light in the form of heat. Dark colours, particularly say black or navy, tend to be more attractive to mosquitoes than lighter colours, mostly because, well, they can see them. Or they can see them better, might be a better way of putting it. In some research, and it varies considerably between different studies, mosquitoes will use colour to identify as to who and what is a potential host or similar for oviposition sites. That's basically where they can find water. Motion detection is another important factor because most of what they're going to feed on is moving, and if it's not moving, it's either not something they can use for food, or it's dead, which means they can still theoretically use it as food, it's probably just not good food for them. It's also why, to an extent, swatting mosquitoes can cause them to chase after you, because they see that something has suddenly moved and they think, well, that clearly is a host. So we come back to this whole issue though. At night time, their vision isn't so great, so they have other senses that are rather more useful. To an extent, some species of mosquito can see in polarized light, and this is more important in terms of their reproduction process, that is egg laying in water, and for recognizing that light is reflecting off of a surface, again primarily water. Beyond sensory mechanisms that are fairly obvious, and not that useful, we have things that aren't vision: chemical, thermal and auditory senses. So we have olfactional, basically smell. They have a antennae that is extremely sensitive, and it has tiny little hairs on it. These are called sensilla. These sensilla don't detect, let's say, motion or anything like that. Rather, they are chemical detectors that pick up on carbon dioxide. This is what you're breathing out, assuming that you're alive. And if you're not alive, it's as your body breaks down. The mosquito can detect these plumes of CO2 between 30 and 50 meters away. This is somewhere around the 150 to 90 foot mark for freedom units. Odor detection is another factor. The human skin does produce a range of odors. Lactic acid, ammonia, and carboxylic acids are some fairly straightforward and well-established examples. All of these are relatively volatile, and what happens is those same antennae, other than picking up CO2, can pick up these other relatively, let's say, volatile odors. It's a reason why sweat and body heat will draw them, partly because clearly you're physically active to producing sweat and body heat, but also that increase in body heat, and to a certain extent sweat, drives those volatile odors off of your body and means that the mosquito has a better chance of detecting them. Some possible host species will also produce certain aromas that are, let's say, more attractive to specific individual species of mosquito. And so, based on the differences in that particular factor, and things like microbes on your skin, genetics, and the odors produced, certain mosquitoes may be more likely to chase you down than others. Then we have thermoreception, literally seeing or feeling heat. A part of this is back to those antennae, and part of it is actually their mouth part, their weird proboscis. This can detect infrared radiation, essentially heat, from warm-blooded people. Humans, typically speaking, are about 37 degrees Celsius or about 98 degrees in freedom units. This is warm enough to emit just enough radiation to be detectable by the mosquito, and will help them, theoretically, target your skin specifically, because that's where they can see the infrared light coming from. Everything else is covered up, and especially in low light conditions like nighttime, when partly you're covered up to avoid things biting you, and partly because it's probably cooled down considerably from the daytime. And then we have humidity sensations. These are hygroreceptors on their antennae again, and these will detect moisture levels. This helps the mosquito track down not only the possible environments for laying eggs, such as water, but also sweaty skin. The sweaty skin indicating that there is something there that they could nom on, or suck on in this case. Then we have auditory sensing, hearing for all intents and purposes. It's noteworthy that there are two different, let's say, sets of preferences here, males and females. Male mosquitoes have their antennae more or less set up to detect the wingbeat frequency of female mosquitoes, about 400 to 500 Hz, and females are rather obviously trying to find a male. There is some evidence, again limited and somewhat less well studied, that they can also detect a certain amount of vibration from various possible sources of food. And finally, we have tactile sensing, literally touch. Mosquitoes have a variety of mechanoreceptors on their legs and on their proboscis, the thing they stick in you to suck out blood. This will help them land and try and find a suitable blood vessel. It's not like they just stick their proboscis, in this case, into any part of your body and go from there. They do need to find some sort of blood supply. They use their feet and proboscis to feel the texture of the skin and detect resistance, along with the things like the infrared receptor vision, which allows them to see the flow of blood, which should indicate that there's considerably more heat. Together, these all work, well, together, rather obviously. Long-range mosquitoes are first going to use things like a CO2 and visual identification to find somewhere that they can target, and someone they can target. As they get closer, they change their approach a little bit. What they do is they rely on heat, humidity, and odor to try and find an area that's not just suitable to land on, but that is a suitable target to land on. And then finally, once they're close up to you, they use their tactile sensors and thermal sensors to figure out where to shove their proboscis into and start sucking out blood. In evolutionary terms, this whole process seems like it should be weird and just unnecessary, but it is a fairly niche way to live, and because it's so niche, well, evolution actually favors it to some extent. The, let's say, sensory adaptations, though, were basically optimized entirely for blood feeding. This means that mosquitoes needed something that would be both vulnerable to their blood-sucking behaviors and to be able to target a wide variety of possible, suitable species. This is why mosquitoes are basically found everywhere in the world. And that's why they survive in, a diverse habitat, whether it's the rainforests of South America, Antarctica, the parts of the Himalayan mountains, or deserts in the middle of nowhere. They survive everywhere. The fact that they can rely on things like CO2 means that they can find things like mammals and birds because they rely on air and metabolism and then produce CO2 as a result. In some cases, though, certain mosquitoes have gone even further, and rather than just being a particular niche, they've tunneled deep into that niche. For example, the Aedes aegypti, which is a particular mosquito species which carries dengue, have basically fine-tuned themselves over time and evolved specific traits to target humans. And humans, not just in general terms, but those in urban settings. This is not just how mosquitoes feed on humans and find us, but it shows that their sensory system has millions of years of not just evolution, but adaptation, meaning mosquitoes are not just very good at finding us, but feeding on us and spreading disease, unfortunately. Things like malaria and dengue. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing, and please do post any comments, questions, or suggestions you have below.